Hi everyone, welcome back to my channel. And in the last video, I showed you how the linear regression is working, and I provide step-by-step example with a numerical example, as you can see here. So if you haven't seen the previous video, please try to watch the previous video. And if you are not familiar with linear regression, and then come back to this lesson. So let's say after calculating in this video, we will try to dive in the performance matrices for linear regression. So whether you are building a model to predict house, let's say house prices, sales, or even someone weights. So if you are predicting continuous values, as you can see here, continuous values as numeric values. So you need to somehow evaluate the model. So in this case we have three, let's see, key matrices. Is RMSE, MAE, and R square score. So we will go through if one by one. So first, RMSA, which stands to root mean square error, as you can see here. So RMSA measure the average magnitude of the error between the predicted and actual values. So it's great to penalizing large error because it's squaring the residual before averaging them. So as you can see here is in this formula here. So we use this formula for the root mean square error. So let's say after the first iteration, right? So please, if you are not familiar, let's say with this stuff, watch the previous video. And let's say I have this weight. This is, let's say, a target, or it's called also dependent variable, which means it depends on all of these variables here. So in this case, we have two. Let's see, and this is the actual value. And if we try to predict, for instance, let's say we have these two values here, and using the previous formula, let's just have a look here. For instance, this one here, and we get y hat. And now I have the actual values of y, which is here, and the predicted values of the y hat, which is extracted, or let's say calculated using this formula here, because only we have two variables. Now you can see that it's super easy. It's just y, for instance, 120 minus 125 plus the second one, 120 minus 155, and taking the average, for because here we have five values here, 1 2 3 4 5, y divided by 5, then calculating the plus, divide by 5, and then take the mean square root error, the let's see, the mean square of this 25. Okay, now let's see. Let's go to the next one. Next about MEA, which means mean absolute error. So in this one here, we can see we have the square and also square root of the values of the difference. But here we have only taking the absolute value between the actual value and the predicted value. You can see 120, which is this one, minus this. And we have no square, no square root. So when we use, I mean, we will see it. So this, I mean, the mean absolute error, it's used when you want to treat all errors equaling. And here it's try to penalize the error before averaging. And let's see, let's go to the R square. So the R square, it's also called as coefficient of determination. So the R square measure how will the model explain the variance in the target values. So, and for this, it's ranging from 0 to 1, where 1 it means a perfect fit, sorry, and 0 means the model perform as well as the mean of the target values. and if it's less than 0, it's perform worse than the mean. So, and here you have the formula here is summation of y minus y hat square, then divided by y minus mean of y. So as you can see here, I have, for instance, the actual values and the predicted values here. So this one here, it's the mean of actual values. So you have to sum of these up and divide by number of these values. For instance, in our case, it's 5 values. As you can see here, just it's easy to find the mean of this of y. Now this is the formula. As you can see, it's just apply just use this numbers, and you can see r square it's 0.92, which means it's somehow let's see as assumption it's a perfect fit. But one one hint here, because we have only using random data, let's say it's a view data, so we can't see the model is perfect or not. So it's just an example to show you how the performance matrices is working, and also the linear regression is working. And also here you can see root mean square is sensitive to outliers and give more weight to large errors. And the mean square, the mean absolute error, it's robust to outliers and provide linear score. And also R square, it's explain how model capture the variance in the data. So for this, I have, for this matrices, you can use skyline matrices. So as I can show you here, one example of this. All of these files will be attached in the Git, and I will give you the link below in the description. And you can see just, for instance, mean square error. You can use import it from this map from this lib, and just use it as it is. So you don't need to program from each matrices by your hand. So it just already exists. So now you might be wondering, when should I use each matrices? So as I mentioned in the brief in the slides, or let's see in the document. So mean square error, when you want to penalize large error model heavily, so you can use this mean square error. When you want to treat all errors equally, you can use mean absolute error. And when you would like to evaluate how well your model explains variance in the target values, you can use this R square. So each matrix has, let's say, strength and weakness, but it depends on your, let's say, needs or target, what you would like to but usually just try to use this mean square error. And I think that's it. And please, I spend more time just to prepare this tutorial and make it for easy for you to understand everything. And if you like this video, please subscribe and like this video. And if you have any also question, please write it down in the comment below. I will answer it. Thanks for watching, and see you next time.